In this lesson, I'll show you how to balance chemical equations. Let's start with question 1. We're asked to write a balanced chemical equation for the reaction between solid cobalt 3 oxide and solid carbon to produce solid cobalt and carbon dioxide gas. As you can tell, we have to create a chemical equation from what we've been given, and the reactants here are solid cobalt 3 oxide and solid carbon. The reactants are on the left side of the equation. Now, how do we write a chemical equation for solid cobalt 3 oxide? Well, cobalt has a charge of 3, according to this number here, and oxygen has a charge of 2. So we have cobalt 2O3. This charge goes to the 3, and the charge of the oxygen goes to the cobalt, plus solid carbon. And you want to denote the state of these compounds. So this element is a state of solid. This is also a solid. And this produces solid cobalt. So we draw an arrow. Solid cobalt will be represented by CO with an S plus carbon dioxide gas, CO2 with a G. Our job is to balance the left side with the right side. What I like to do to balance chemical equations is to write down the atoms that are on both sides. So we have CO on the left side, oxygen and carbon. And of course, we're going to have the same ones on the other side. CO, O, and C. Technically, I'm creating a small chart. We have 2 cobalts, notice the subscript of 2, 3 oxygens, the subscript, and only 1 carbon. On the right side, we have 1 cobalt. Notice there's no subscript. We have 1 carbon, and we have 2 oxygens. So far, as you can tell, without even balancing it, the carbons are balanced, but these 2 elements are not. What I can do to start is multiply this cobalt by 2. So I put a coefficient of 2. This is called a coefficient. A number in front of the compound is called a coefficient. If I multiply CO, which is 1 by 2, I end up with 2 cobalt. So now the cobalts are balanced, and the carbons. Although the problem now is with oxygen. We have 3 on the left side, 2 on the right side. Somehow we have to make them the same. What I can do is multiply this molecule by 3. And if I multiply it by 3, look what happens. The amount of carbons change, it becomes a 3. And the amount of oxygens, we have 3 times 2, which is 6. Now, how can I counterbalance that on the left side? Well, I can multiply this compound by 2. And if I do that, this time I have 4 COs. Notice we have 2 times 2, 4 cobalts. And 2 times 3 is 6 oxygen. So the oxygens are balanced, but the cobalts and the carbons are not. That's fine. I can change this 2 into a 4, and that will make the cobalts on the right side a 4. Remember that this is a balancing act, so you may have to go back and forth until you finally get a balanced chemical equation. The cobalts are balanced, the oxygens are balanced, the carbons are not, but that's not a problem. All I have to do is put a 3 at the front. Now we have 3 carbons on the left side, 3 on the right side, and everything else is balanced. And there you have it. That is how to balance chemical equations. Make sure to watch question 2, 3, and 4, where I'll show you other methods on how to balance chemical equations. Hope to see you soon.